Ways to find zeros of polynomial functions is section 4.4, theorems of zeros of polynomial functions. And um, we may have to split this video into a few because honestly this is one of the toughest sections that we look at all semester, not because it's hard to understand, but there's a lot of algebra involved when you start distributing these factors. So the first set of problems say to find a polynomial function of degree 3, and they give us the zeros. So I'm going to do a few of these. Like in problem number 1, they tell me that the zeros are -2, +3, and 5. Alright, if those are the zeros, then my factors will be if -2 is a 0, then x plus 2 is a factor. Remember from an earlier section we looked at if x plus 2 was the factor, what was the 0? We went backwards. So this is just kind of going the other direction. If 3 is a 0, then x minus 3 is a factor. And if 5 is a 0, then x minus 5 is a factor. So really now all I have to do is multiply this out and write it as a polynomial function. So you multiply any two that you want to. I'm going to multiply the last two. And if I do that, x times x would be x squared. My outer would be minus 5x and minus 3x, which would make minus 8x. And then -3 times -5 is positive 15. So now I have to multiply x plus 2 times x squared minus 8x plus 15. And I get x cubed minus 8x squared plus 15x plus 2x squared minus 16x plus 30. I just went through and multiplied everything by x and then everything by 2. So I get x cubed minus 6x squared minus x plus 30 when I combine my like terms, because these two go together to make minus 6x squared, and then the 15x and the negative 16x go together to make negative x. So that would be my answer for that particular problem. Alright, well what if I have a problem that instead of having all integers, it has some square roots, like problem number 6. What if I have my zeros are -5, the square root of 3, and the negative square root of 3? These come in pairs, so if I have one, I have to have the other. So my factors would be x plus 5, x minus the square root of 3, sorry about that writing, it ran together, and x plus the square root of 3. And I've got to distribute all these factors out. I would multiply the ones with the square roots first. You don't have to. You can do the other two first. I think it's a little bit more difficult to do that. So x times x is x squared, and then my outer would be plus the square root of 3x, and then I'd have minus the square root of 3x, and then minus the square root of 9, which would be x squared, and this cancels, minus 3. So distribute this, it'd be x cubed plus 5x squared minus 3x minus 15. And that's how that multiplies. Sometimes we have complex numbers that have to be multiplied, like problem number 9. 1 plus 6i, 1 minus 6i, and -4. Okay, if f of x equals, if 1 plus 6i is a 0, then my factor is x minus this, which would be -1 and minus 6i. If this is a 0, then my factor is x minus this 0, which would be -1 and plus 6i. And then if this is a 0, it'd be x minus -4, which is x plus 4. Okay, if I treat these, I'll just go ahead and do it the longer way. X times x is x squared. I'm going to do x times everything first. X times x is x squared. X times -1 is minus x. X times 6i is 6ix. Now I'm going to do -1 times all three. -1 times x is minus x. -1 times -1 is plus 1. And -1 times 6i is minus 6i. Now I'm going to do -6i times all this. -6i times x is minus 6ix. -6i times -1 is plus 6i. And -6i times positive 6i is minus 36i squared. And then I still have x plus 4. Okay. The plus 6ix and the minus 6ix cancel out. The minus 6i and the plus 6i cancel out. I have x squared minus 2x plus 1, and this would be plus 36. Or x squared minus 2x plus 37 times x plus 4, which is x cubed plus 4x squared minus 2x squared minus 8x plus 37x plus 148. 37 times 4 is 148. So my answer to this would be x cubed plus 2x squared plus 29x, that's negative 8 and 37, plus 148, and that would be my answer. It's a little bit harder when you're multiplying these out, but this is real similar to problem number 10 that you have to do. So you may want to pause this one or take a screenshot of it as you're working on number 10. Number 15 is they just tell you what the zeros are and they want you to find the polynomial function. So I'll do number 16. It's very similar to number 15. They tell me it's going to have a degree of 5, and they say negative 1/2 is a 0 with multiplicity of 2. 0 has a multiplicity of 1, and 1 is a 0 with a multiplicity of 2. So that means I'm going to have x plus 1/2 twice. I'm going to have x once, because if 0 is a 0, it's just x, and that's just once. And then I'm going to have x minus 1 twice. So I'm going to multiply all these out. If I do the first two, I get x squared plus 1/2 x plus 1/2 x, which would just be x, plus 1/2 times 1/2 is 1/4. And then I've got an x here. And then if I multiply these last two, it would be x squared minus 2x plus 1. I'm going to go ahead and multiply the first one time. I'm going to do the last one times x, because this one has a fraction. This would be x cubed minus 2x squared plus x. Okay, now I'm going to do everything here times everything here. So that's going to be x to the 5th minus 2x to the 4th plus x to the 3rd. That's x squared times all three. Do x times all three. That's x to the 4th minus 2x cubed plus x squared. And then 1/4 x to the 3rd minus 1/4 times 2 would be 1/2 x squared. And then 1/4 times x would be 1/4 x. Which will be x to the 5th minus x to the 4th. I got x cubed minus x cubed plus 1/4, which would be negative 3/4 x cubed. I've got a x squared minus a half x squared, which would be a half x squared, and then a 1/4 x. And honestly, looking at this, instead of this being x plus 1/2, I could have made it 2x plus 1. That would still give me a negative 1/2. That might have been a little bit easier when I was multiplying out and not having a fraction. This is acceptable and a good answer. So anyhow, that would be an answer to one like problem number 15, which doesn't have any fractions. So it should be a little bit easier. Just in 15, you're going to list the factors as many times as it says you have multiplicities, and just multiply them out. All right, I'm going to stop here, and then we're going to talk about pairs of zeros and how that works.